In the next problem, we have a particle starting at time t equals 0 and moving on a number line so that its position at time t is given by x of t is equal to t minus 2 quantity cubed times t minus 6. And we'll first ask, when is the particle moving right? And I usually write down what it is that I need to show. That it will be moving right when v of t is greater than 0. By using the chain rule, by using a product rule and a chain rule within the product rule. So the derivative is going to be, basically it's a product rule, where the first function is t minus 2 to the third and the second function is t minus 6. So 1d2 plus 2d1. So the derivative of the first term again is 3 times t minus 2 to the second times the derivative of t minus 2, which is 1. Alright, so we have t minus 2 cubed times 1, which is just t minus 2 cubed, plus 3 times t minus 6 times t minus 2 squared. In order to factor this, we should factor out a t minus 2 squared term, and that would leave t minus 2 plus 3t minus 18, and so that would give t minus 2 squared times 4t minus 20, and finally 4 times quantity t minus 2 squared times t minus 5. Alright, so that gives us the velocity in factored form. We can see clearly that we have zeros at t equals 2 and t equals 5. And so I set up my sign chart. Remember, what I'm trying to determine here is when is the velocity positive. So on each of those sub-intervals I choose some test points and I'm going to plug in 1. I should use the factored form. It would be easiest. So when t is 1, I get 1 minus 2. T minus 2 quantity squared will always be positive. 1 minus 5 will be negative. That will make the whole thing negative. Plug in 3. 3 minus 5 is still negative, so the whole thing will be negative. Plug in 6, and this time everything will be positive. Alright, so when is the particle moving to the right? Only for time greater than 5. And so I supply my answer. It's up at the top where I gave my justification or my reasoning. It's not enough just to do a sign chart and leave it there. You must answer the question explicitly. Next, when is the particle at rest? Translated into calculus, it will be at rest when v of t is equal to 0, and that is at t equals 2 and t equals 5. Okay, that's the third part there. When does the particle change directions? We can see that it only changes directions when v of t changes sign, and that will be at t equals 5. Alright, so I've answered all three of those questions just using the information provided by the derivative and the sign chart. And I would like to call your attention to the way that I answered the questions. I show my reasoning in each step in a very simple way. I'm justifying what I'm doing at the same time. Okay, we'll go on to part D. And it asks, what is the farthest to the left of the origin that the particle moves? Well, we see the sign chart that the particle starts out moving to the left and continues moving to the left until it reaches time t equals 5, and then it starts moving to the right. So the main thing we need to ask here is, where is the particle at time t equals 0? Alright, so plugging in 0 into the original function, into the position function, should give us x of 0 equals 48. Since the particle continues to move until t equals 5, and x of 5 is negative 27, so the particle started at position 48 and moved left until time t equals 5, at which point it was at x equals negative 27, and then it turned around and started moving to the right, towards the origin. Okay, so let me see if I can spell this out then. Since the particle begins at time t equals 0 at position 48, and since it's moving left from time t equals 0 to t equals 5, we know that at t equals 5 it's going to be at its furthest point to the left, since it changes direction at t equals 5 and starts moving to the right again. So the furthest the position will be to the left of the origin is negative 27.